All right. One thing I meant to mention last time was this may or may not apply to you. And don't think for a second I'm speaking specifically to any particular person. Last semester, we had a very weird results. People did really well or really poorly, right? And there are very few people that were kind of in between. But there are going to be people in here that were the people that kind of fell in between, where they got by with like a 50-something, which is fine. But I'm giving you this warning, if this is you, I'm giving you this warning now. It's not just like a 50 or a 60-something, whatever. The warning I'm giving you is you are in no way set up for failure in this class. No, 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 no. I want you to be here. If you're here, you probably kind of want to be here, and you can definitely do it. Absolutely, you can. But understand that you do have a bit, like you're going to be on your back foot, but it is recoverable at this stage, because we are kind of like, we are having a moment of like shifting gears. And the first chunk of this class really is a lot of review of the end of the last semester stuff. What we're going to be doing is kind of like the last chunk of 161, again, for a little bit, for like a week or so, in 162, we're going to be doing the same stuff, but in Java. So it's a chance to give, like if you are that person that was like kind of like just squeaked through, but are here and you want to be here, you have the perfect opportunity to like get on top of it to set yourself up for the best success possible. So don't, if you're kind of like, oh man, I don't know, you are in the best position possible to be successful with how the course is designed to go. All right? So that's all the warning or pep talk, whatever you want to call it, I'm giving you, okay? All right. Yes, I am recording. All right, this is where we kind of like left off last time, right? I vaguely talked about stacks and queues and this like bag, which is kind of just like a list, a tree, a graph. These are all like abstract data types. And we really ended on the idea of kind of the separation between the definition of what this thing is and what you can do with it versus how it does what it does. There's a difference between the what and the how. The what is, what can I do with the list? The how is, how does the list work under the hood? Obviously, these things are connected, but we want to think of these things as separate as possible, and it helps us a lot. And this is a general good design principle, not just for computing, but for like everything, okay? So you want to have these things separate. Like I was saying, you know how to interface with a car, and if your next vehicle is an electric car, you're going to be just fine. You don't need to relearn how to interact with this thing, right? Sure, it'll have some quirks, fine, whatever. But the way you interface with the car is the same. Your pedals and your steering wheel, right? It's the same, regardless of what's under the hood. How you interact with the car is kept the same. Imagine if it wasn't. That would be ridiculous, right? That would be stupid. No, it was good design, okay? Cool. So the abstract data type is the high-level idea of, oh, here's a stack, here's a list. What can I do with the list? An implementation is like, well, what it actually is. Right now, when we talked about these stacks, these queues, these graphs, these trees, these bags, these lists, this car, we were talking about the what, not the how. We didn't talk about any specific implementation details or issues. And a specific implementation, though, because we will be implementing these things, we will define a stack and then we're going to make our own stack. We're going to build one that we can use. So we will be doing both, but we're being clear to kind of set that line, that boundary of like, okay, on this side, we're talking about like, what is it? And on this side of that boundary, we're talking about the how does it do what it's supposed to do? How do I implement the what? We're doing both, but let's make sure that that line, that barrier doesn't disappear. So a specific implementation of an abstract data type is going to be called a data structure. For example, and this is using some like Java conventions here, but like the stack ADT could be implemented with an array. An array, which we're going to talk about, is kind of like a dumbed down version of a list, but it's actually a little bit more like basic in a good way. Or we can implement a queue with a link structure. So we can have the queue ADT is implemented with a series of linked nodes. We might call this a linked queue. These are all things we're going to be learning about weeks from now. So don't worry, we're jumping ahead with this presentation right here. But we're going to keep these things separate. What else did I want to say about this? I will warn you that it is very typical for people, I will too, I know I will, for people to kind of like really butcher the use of like abstract data type, data structure, collection. They all kind of have very special meanings, but people tend to kind of use them interchangeably, and we know what we're talking about based on the context, but there is technically a precise difference between these things. Kind of like parameters and arguments. You remember me last semester? The arguments are like the values, the parameters are like the variables. They're like, but people kind of misuse them. I'll call like the parameters arguments. People call the arguments parameters all the time. That's normal. I mess it up. I try to be precise and correct, but most people are kind of mixing and matching. We know what we're talking about based on the context. Is my volume okay? Everyone in here can hear me pretty good? It's nice. I don't have to yell as loud. In 2070, I got to really go for it. All right, Java. So we're going to be switching programming languages to Java, like we talked about lastly. Like what about Python? Well, don't worry. First of all, Python ain't going anywhere. It's still going to be around when we're done this course. And if you're worried about switching to Java, you really shouldn't be. There is obviously going to be a little bit of like a learning curve of like, okay, you have to switch gears to Java, but you're going to very quickly realize how similar Java and Python is. All of the core main concepts, like your ifs, your for loops, your functions, your classes, your blah, 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 they are in both languages. There's going to be some conventions that are a little different, and just the way you have to do things are a little bit different. And there are some different requirements, all of which we're going to cover, which will feel like a bit of a jump. But you got to figure like if you know what a linear search is, then like if I know what a linear search is, and you are supposed to go implement it in Python, okay, I go implement in Python. But if you don't know Java and you need to implement a linear search in Java, you go like, okay, I need to do a linear search. Well, what do I have to do? Well, I need like, I've got my linear collection, I need to iterate over, okay, so I need a loop. How do I do a loop in Java? Like if you know what you need to do, so the question is just like, it's an exercise of like, well, how do I do what I know I need to do, but in Java? The important thing is you know what a linear search is. That's what's important. Java, that's, you know, a side effect of the course, that fact that we're using Java. So try not, like, don't get too worried. Most students, like I find, like anecdotally over the past few years, and it was the same with C++ too, when this course used to be with C++, when I went from Python to C++, students would feel like for the first week or so, they would be like, man, this is so hard. Switching to Java, this is so hard. Oh my gosh, it's way too steep. I hate them. And then like after that point, they'd be like, oh wait, no, that was stupid. That was so easy. So don't feel discouraged if it feels really tough, because you are likely, if past tells me anything, you're likely going to get to a point where you're like, oh yeah, what was I thinking? This is trivial. Trivial isn't the right word, but it's simple, let's say. Okay, the transition. So don't get too discouraged. The first chunk of the course is going to be like, here's some comparisons. How do you did what we did in Python and Java, and so on. The first assignment is the same assignment as assignment 4 from 161, but in Java. There are some little differences, but it's an exercise of, you know, implementing the same ideas in Java. By the way, maybe start looking at doing assignment 1 if you want to start getting used to it. I don't have a deadline set for that. I'll come up with one soon, but yeah. All right. Whatever. As we go, there will be some like Java-isms, like things that Java requires you to do that you're not going to be familiar with. I'll make it as clear as I can as I go. If it seems like one is presenting itself and I'm not really hitting it, be like, what is that? Oh yeah, I'll explain it. Python's flexibility also, I really feel, starts to get in the way as our software grows in complexity. As our problems get more complex and our solutions to those problems get more complex, Python's flexibility actually becomes a bit of a problem, I think, for new programmers. To be clear, Java is not a learning objective for this course. It's not an explicit learning objective. This course is about data structures. It has nothing to do with Java or any other programming language for that matter. I could teach this to you in whatever language I want. But it is obviously like an implicit learning objective. You're necessarily going to be learning Java as we go, but the point, like, I'm not teaching you Java. I'm going to be teaching you some Java, don't get me wrong. But this course isn't about Java. It's about data structures. So how do I go about programming in Java? You go here, and you get set up, like I told you. So you get everything ready to go. You get your JDK, and you get your IDE, IntelliJ, and you're all set. And here's an example of hello world in Python that we're familiar with, right? Hello world, right? Print hello world. And here's an example of the same thing in Java. And you're immediately going to look at this. I know what you're thinking. You're saying like, whoa, look at all that crap I need in Java. Yeah, you're not wrong. One of the criticisms of Java as a programming language is how insanely verbose it is. It is. These two things achieve the same thing. It's hello world. But look at all that extra stuff. But this is a bit of an unfair advantage because Python kind of does have like this main thing. This is a function called a main method, really. Here's a Java-ism, and this is something I'll repeat several times, and this isn't something you need to commit to memory. Here's something to know. There's no such thing as a function in Java. Everything is a method. And if you remember from 161, what are methods? Well, methods are functions that are associated with a specific object, right? So it's like a method, but on an object. You tell an object to perform a method, right? But we have things called static methods. Static is a concept we're going to be covering a little later, but a static method is a fancy way to basically make a function. But it's totally not a function, but it's a function. But it's not a function, it's a static method, but everyone knows it's a function. So long story short, this is main. Whenever you hit run in your code, on any programming language, well, on many programming languages, whenever you hit run, there is a first line of code that is to be run in your code. In Python, it was often the first line of the script that you're running, right? But in most programming languages, in many programming languages, the first line that's going to be run is actually the first line of the main function. When you hit run, your computer calls this function, the main. Main is a very special word. It needs to be called main. If your program doesn't have a main, and you hit run, Java's going to be like, there's no main. If you spell it with a capital M, it's going to say there's no main. It needs to be M-A-I-N. That's a special function. That is, when I hit run, that's the code that gets run. And everything in Java is in a class. It's an object, so we need to define a class. And we've seen classes in Python. But this is just there because everything we write in Java needs to be there. This is main. It just needs to be there. Technically, there's kind of a main in Python, but you don't have to write it explicitly. So even though, yeah, there's a lot more lines of code here for hello world in Java, in terms of like what's doing the printing out hello world, it's still one line of code in both. It's the print hello world versus system.out.println hello world. Anyone know what println means? Print line. It means print and then add a new line to the end. There is a print where you just type print and you do that, but it won't automatically go to the new line, FYI. So there's actually like two different print methods like that. There's print and then println. Print will just print something out, and then if I print again, it continues on that line, where println will automatically go to the new line every time, like how Python's print worked, FYI. So let me open up IntelliJ. Let's just get rid of this, whatever. System.out.print line hi, and let's hit run. Run. There's a lot of ways to run. I ran it one of the many ways. And what are we going to see? We're going to see the JDK. It's doing all its thing. And then, oh, there, hi, there we go. Cool. All right, there we go. And what I mean by print versus println, this is not something that you need to be like, oh, this is going to be on the test. No, this is just something you'll learn as you go. Like if I run this, watch what happens. You know, hi, new line, bye. But if I don't do the new lines, new ln, they are different functions or methods, static methods. You see it's just, you know, like that. Cool? Cool. So Java does have a lot of boilerplate code, stuff that's kind of got to be there. It's very verbose. But other than that, it really is like the same as Python, right? System.out.println is doing the same job as print. And then print takes some argument, and then what does it do? Well, that's what it displays to the screen. If you remember from 161, outputting any information from your program is very side effect-y. We don't need to go into more details than that, but it's very side effect-y. But one thing you might notice, I mean, there are a number of things you might notice, but one thing you may also notice is that now, I was very careful in Python, although I did make mistakes, for lack of a better term, where, like in Python, if I have a string, I can use single quotes or double quotes to define my string, right? It didn't matter. There were pros and cons to each. Does this sound familiar? Yeah. In Java, you want a string, it's got to be double quotes. You cannot do this. Whoop. You can't do that. In fact, it's even yelling at me. It's saying, hey, we got a problem. I wonder what it actually says. What does it say? Too many characters in character literal. Well, what does that mean? Well, single quote has a different meaning in Java. Because there's another type, another primitive type that's in Java. It's in there Python too, but we don't really talk about it or use it very often. It's kind of like hidden. But a single quote is what you would use for a single character. So if I wanted the character H, I would use the single quotes. You might ask, well, can I have the string of the single character H? Yeah, you could. But they're actually different types. Because remember how in Python, strings were different, right? Remember we had like integers. How much room does an integer take up? Well, whatever, 32 bits, 64 bits, whatever. Like how much room? I know how much room they take up. A Boolean, I know how much room they take up, right? I can put a single integer in a single seat. But if I have a string, I have a bunch of characters. How many? Like I can't put 20 characters in a single seat. So strings were different, right? It was a collection. It was a linear collection, really. Letters followed by letters followed by letters. Well, in Java and many other languages, a single character is actually another primitive type. Unlike strings, like, well, how much room does an individual character take up? Enough to sit their butt right in this seat. It's fine. A string really is a collection of characters. So a string in Java, like in Python, is actually like, it's an object, where an individual character is a primitive type in the same way that an integer or a float or a Boolean is. Some interesting thing. Most people aren't ever using individual characters for our needs. Like, I don't think we're using them this semester. They're useful, don't get me wrong. But, yeah, just a neat little piece of trivia there. Any questions about that? Don't get too bogged down by this. Don't be like, oh, is this course going to be all this weird trivia about? No, I'm just showing you some nuance at this point for fun of it. Questions, thoughts, concerns, comments before we go on? What else do you see in this code that you're left going like, wait, what? Be honest, because there should be a lot. What do you see? Void. Yeah, what's void? Anything else? What else do you see that's a little weird?
I don't know. There's a bunch of like, what do you call it? Like the little brackets.
Oh, the braces, the squiggles. Yeah, the squiggles. What else do you see? Args, ARGS, yeah. What else do you see? The semicolon. What else? Come on, wake up. What do you see? Static. String with the empty brackets. There's a lot of stuff going on here. What else do we see?
Comment with double slash.
Oh yeah, comment is double slash, not the number sign anymore.
you run the code without the file name some class it won't run?
That's a good one. That's actually a really good thing. Good observation. So I have in this thing here, my class's name is main. This is arguably a bad decision because the name main and the main that's but it's called main. The name of this class in Java must match the name of the file. It must. If it doesn't, it ain't gonna work. FYI. But good observation. So the name of the class, which is you'll only ever write at the top line of the file. Here, the name of this class is main. I probably shouldn't have done that. This was just a screwing around example, as you can see by the name of the project. The name is main, which is weird because now I've got like a name. It's not a conflict because uppercase M-A-I-N versus lowercase M-A-I-N are two entirely different things, but you know, us as humans are gonna go like main. Is that important? No, it's not. That should be called like, well, literally anything else useful, right? But remember how in Python, the name of our classes should always start with an uppercase, right? Oh, same within Java. Does it have to? No. But do you have to? Yes. Okay. Basically, will it work? Yes. Will Java programmers start hunting you? Yes. They will be mad at you. So the name of this and the name of the file must match. So if I called this like QWERTY, look, it's even saying I ain't gonna run that. And what is it gonna yell at me? What's it gonna say? Nope. Should be declared in a file name. It's telling me like, look, this is handy. The JDK is being like, look, your file name is wrong. So let's rename it. What is it? How do I do this in Java, in IntelliJ? All right. Refactor. Now, calling it all uppercase is also perhaps bad. You know what? Let's do this right. There. There. And now it'll be happy because the names of the files match. There. Yeah. Good note. And also there's this like public keyword. Well, you know, we kind of talked about that vaguely in 161 as an idea, not as an actual keyword. All of these things will become quite clear as we go. The weirdest one of them, I would say, is going to be static. It's not that bad, but it probably is objectively the weirdest one. So yeah, public, class, static, void, main, string, arg, squiggle. There's a lot. So what does public mean? Well, this is the visibility modifier, right? Remember how in Python, how like look, this is a constructor in Python, right? But remember how like those attributes, those fields, like first name, last name, student number, and current average, those values, they're associated with a specific instance of I don't remember what this is from, probably like a student object, right? But we didn't want those things to be accessible from like outside the class, right? So we signaled to other programmers and to ourselves that this is a value that exists inside this class, but no one should be able to access these fields directly from outside the class. And we signified that with an underscore, right? In Python, that didn't stop you from doing it. I could say my instance of a student dot underscore first name equals totally not whatever their first name was. I could do that, but you know, I'd be breaking the rules and I'd be in trouble for that. In Java, on the other hand, I could specify these things to actually be very explicitly, I could specify them as private. And that would completely disallow me from modifying those things. So the keyword actually enforces, like the language forces it such that it can't change. I'll show you an example of this. Let's create a new class. Let's call it A. a student object. Now, I'm kind of jumping ahead, but for the sake of demonstration, I'm going to show you right now. In Java, you create your attributes before you write your constructor. Private string first name. I'm just going to have a first name. And then I'm going to create a constructor. All right? Public. Again, private and public are the two most popular visibility modifiers. There are two other ones. There's private and there's protected and packaged private. We're not going to use those ones. I think we use protected once. It's a very niche one that we would use in this course. But public and private, basically, can this be accessed and modified elsewhere? Can this not be accessed or modified elsewhere? Classes are usually public because, well, if they want to be used elsewhere, if you're writing it to be used elsewhere, you want it to be used elsewhere. Constructors are usually public, usually, because if you want it to be used, I need to be able to access and create the constructor. But let's say public student string first name. Look at this. It's got like autocomplete. This is wild. Look at this. It has like the AI built in. Ooh. There we go. Cool. So what's going on? Well, this is a constructor in Java, right? Instead of underscore underscore init underscore underscore, the name of the constructor matches the name of the file. Or sorry, the name of the class, which matches the name of the file. Okay? Again, I'm jumping ahead, so don't be too worried. But see how this is labeled private. Okay? So if I go into here and I want to make a, okay, I'll say my student equals a new student. And what should their name be? Somebody give me a name. Jacob. There we go. Cool. And then if I want to say, oops, oh, I was foolish. And then if I want to say, okay, my student dot, what was it, first name, right? If I want to do something with it, first name, it's saying like, hey, look, that was set to be private, but you're trying to access it from outside the student class. This is the QWERTY class. I'm trying to access it. You can't do that. And this isn't just a case of like, oh, it's warning you about it. No, this is a case of Java's gone, nope. Well, now it's mad because this isn't a statement. Although that might still not be a statement after this change because it's a nonsense statement. Like Java won't even run. It's like, no, you can't do that. It's private. Can't do it. But if I make it public, on the other hand, I can access it directly. So where in Python we used underscores to signify whether it was private or not, but it never really enforced it, in Java we use the keyword public and private, and it actually enforces it, which is awesome. It gives us, the programmer, more control over how our code is used, and that's a good thing, a very good thing. Anyways, so this is, okay, yeah. Okay, we're going to be talking about this more later. Yeah?
Can you write code without creating classes?
Say that again.
Can you write code without creating a class? Writing code in like...
So you would still need, there are such things as like Java interpreters, and in those cases I guess you probably don't need a class. But even like to have your main has to exist in a class. So like, yeah, you do. Yeah. You had a question?
Does indentation matter?
Indentation, so, you know, okay, we're jumping ahead, but indentation doesn't matter. Hit run. We can run, well, yeah, we can run this. And it's entirely fine. Indentation does not matter. However, indentation matters. Don't ever do this. Do not ever do this. You still use the indentation. The indentation is a design thing for readability, okay? Really, this is wrong. I mean, it's fine, but it's wrong. So really, I don't even need these things on separate lines. They could all be on one line. That's entirely fine. It's not, but it is. Because in Java and many other languages, it's not the indentation that matters. The indentation still follows the same principle as Python, all right? But remember how in Python, like, indentation meant like, okay, if I'm writing a function, everything indented is in that function, right? Well, now, here's my function or my method, main, open squiggle, close squiggle. That's everything in there, all right? Open, close, that's everything in the class. So this open and close brackets or squiggles or they're called braces. I call them squiggles. That's how you define what's in there. And in Python, a statement was ended by a new line. In Java, statements are ended with a semicolon. Now, you might say, how come that didn't have a semicolon? Well, it's a little different, but don't worry right now. Right? So statements are ended with semicolons. Long story short, chances are half of you will add semicolons to the end of your for loop definition and your for loop won't work right, and then you and me will be scratching our head for 5 minutes being like, but it's fine, only to discover the semicolon was there and like, curses. But this is something you'll get used to. When do you add a semicolon, when not? Anything with like the squiggles, don't add semicolons. Just like lines of code though, like semicolons.
How many points will I lose if I try to submit assignments in SQ1?
All of them. All of them.
You actually get negative points.
Yes. Yes. All right, class. The class keyword, that has the same meaning as Python. It means the same thing. I'm going to define a class. If you don't remember what a class is, we'll kind of review it, but you should probably remember what a class is. Static. Static, there's nuance to this. I'm going to explain it now. I'm not expecting you to understand it completely now. That would be a little ridiculous because this makes more sense like when you have context. But when you say something is static, it means that that function or variable, because it can be a value, if you have some function or method, whatever, or variable belongs to the class and not a specific instance of a class, right? Remember how like on assignment 4 in 161, like calculate, population density was one of the things, right? There was like a population density function or method. I needed to have an instance of a country, and then I could ask that country, hey, what's your population density, right? So I had to have an instance of that class before I could call a method on it. But sometimes we might have functions or data that I want to be able to call, but don't really depend on an existence of some instance of that class. We're going to see a lot of examples of this at this point, or as we go. But like a simple example is going to be like Java's math class, right? So if you go open up the math class, you're going to see things like absolute value, add, arctan, cos, a lot. There's a lot of crap in here, okay? There's a lot, right? And these are all static methods or values, because there's like pi in here. Yeah, pi and e, right? They are static, meaning I don't need to make an instance of a math object and then ask that instance to perform cosine. I could just call it directly. Don't worry right now. This will make sense as you go once you have more context.
What would the keyword be other than static?
I don't know.
You don't know.
What do you, like, what, like, I don't know, it's static.
It's not like mobile.
I don't know. That's funny though. Wait, was that, sorry?
Like, is it like dynamic or something?
What's the opposite? No, I don't really know. Static just means like it's belongs to the class, and I haven't really thought into like the etymology of the word in this context. I just know that it means like, oh, it belongs to the class and not an instance of the class.
So would you just not put static?
You don't say it. Nothing. Yeah, yeah. If you don't say static, it's not static, whatever that means. All right. So like, yeah, this is what I mean is like, imagine I had a class called some class. and I had a method in there, if I made that method static, if I had a static method, I would call it like this. I would say, like, okay, some class, this is the name of a class, some static function. If I had a non-static method, I would have to have an instance of some class. This is how I make an instance of a class. And then I would ask that instance to perform some method. I can't ask an instance to perform a static one. Actually, I can, but you shouldn't. And you can't ask a class to perform like an instance method. FYI. This is the one that I was warning you is like the weirdest one. It's really not that bad, but without more context, it's kind of hard to see. Especially because this is a kind of a consequence more of like Java. You have a question? I don't want to get too, like, I've spent too much time talking about this today, and I'm making it seem like more of a bigger deal right now than it is, to be clear. But do you have a question?
You don't have to answer, but what is an example of an instant method?
An instance method would be like population density. Or like, yeah, that would be an instance method. Just a not static one. Void. Remember how, okay, so everything in Java has to have a type associated with its value, okay? We're going to see a lot of examples of this as we go. So, like every function returns something, right? Remember how, in Python, every function returns something. And even if it didn't, it did. It returned that magic none, right? Now, because everything is so strongly typed in Java, whenever you write a method or a static method function, you actually have to specify, like if you give that function some parameters, you have to specify the types of those parameters. You're going to get 2 integers, okay? We're going to see a lot of examples of this. But you also must say, what is the return type of this function? Like if I'm writing the function add that takes 2 integers, it's going to give me back an integer. So I have to tell the function, hey, you're going to give me back an integer. But sometimes you have functions that don't return anything. So what do you write? You write void. Here's a function that's not going to return anything. It's void. Main doesn't return anything. It's void. Right? Its return type is void. We're going to see a lot of examples of this. Main, like I said, this is a very, 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 very special function. This is the function that gets called. When I run my program, the first line of the main method is what actually runs. It must be called main, lowercase m. There we go. And then string args. Main is a function or a static method. And functions can take arguments, right? We've seen this a lot, right? They have parameters. Turns out your main, when you hit run on a program, you can give your program arguments. However, let's pretend it's 1979 and you're running your program. And I'm running my program like, okay, my program. And I hit enter and it would run, right? It's not because that's nonsense that I wrote into here. But like that's how I would run my program, right? Like there. It's 1985 or whatever, and I'm typing away, right? And this is how I interact with my computer, like this. Which, by the way, this is a way better interact with your computer than GUIs. Ugh, GUIs. Wait. Raise your hand if you don't know what I mean when I say GUI. Okay, you're normal. GUI means graphical user interface. All right, so that's like what you're used to, your Windows and everything, right? Yeah. What? A GUI, a GUI, yeah. So, okay, my program, assuming this is a program and I hit run, it goes and it runs the first line of your main. But it actually, your program can take arguments. Like some value, some other value. Maybe it's a function that just takes 2 numbers and adds them together, right? We could write a simple function like that. Well, that string args would be those arguments. But you might say, well, hold on. So first of all, hey, when you call a function, you need parentheses. Yeah, but this isn't Java. This is your operating system calling a program. So to be clear, that's different. It's just name of the program followed by a list of some list of arguments. Okay? Now you might say, well, hold on, you put 2 there. You've got the name of the program, fine, but now you've got 2 arguments. But you said string args, it's only 1. There's 1 string. No. No, that's not what's happening at all. What this means is that's an array. Basically, it's a list of strings. And that could be arbitrarily long. So in the end, I have a list of strings. It's not a list, though. It's an array. But I'm calling it a list now for simplicity, because that's what we're used to. We have a list of strings called args. And in the indexes of that list are the various values. That's all. This ain't going to matter at all for this course. I'm just telling it to you so you know what it means. It's pretty neat, but we're not going to use it. I'm used to make y'all use it, but students would always complain about it because they're like, what is this? I hate this. And I'm like, fine, forget it. It doesn't matter. Yeah?
So does it need to be called args?
I don't actually know. Maybe not. I don't know. I actually don't know. But let me put it this way. If it doesn't need to, but you don't, you messed up. Okay, yeah. That's all. Yeah. Yeah. Cool. Args, yeah. It's not just Java. Everything calls them args, but yeah. Void, main, string, whatever. Okay, yeah. This defines a variable called args that is an array of strings. This is how we give program command line arguments, basically parameters, you know. More on this later, not overly important. I think this is a lie. I don't think we get more on this later. And the squiggles, I already said that's how we bind. Like, okay, everything within this and this is in this function, for example. And they could be nested. You could have an open, and then like an if with an open, and then a loop in there with an open, and so on. They could be nested out, you know. But yeah, an open and then a closed. Cool? Questions, thoughts, concerns, comments, anything? Yes?
Can you explain void again?
Void. It's basically, here's why I'm not going to worry about it right now, because we're going to see examples of it that I think are going to be pretty, you know what, let me just show you an example. I'm going to write a static method. Public, static, nope, public static, int, add, int A, int B. Man, this is wild. Oh my gosh, I should turn this off. First of all, it's great when you're asking it to do something this stupid. Probably going to be messing up a lot, but there. So this is a function. It's a static method. And the reason it's static is because I'm not making this belong to an instance of any class. I can say, how do I want to do this? Okay, let's say, okay, int the equals add 4 and 5, right? And then here I'll say the result. And I can hit run, run, run. And we should hopefully see a 9 come out. There we go, great. Okay, cool. This is a function. It's public because I want to be able to see. It doesn't actually need to be public here. I don't need to say public. The reason I don't need to is because it's like in here. It could be private. It doesn't really matter. But I'll just, leave it there. Yeah. So it's public. It's static, meaning I don't need to have an instance of a QWERTY object to call this method. I could just call it. Its return type is integer. When I call it, it's going to give me back an integer. And it's called add, and it takes an integer I'm calling A, and an integer I'm calling B, and then we're returning the sum of A and B. It's a stupid, simple function, but whatever. I specify what it's returning. When I call it, and then Python or Java does this thing where it makes sure everything is type safe, right? It goes, before it runs, it's going to go like, is that an integer? It's expecting an integer. Is it an integer? Let me show you too. If I do something like this, it's going to be like, no. That ain't an integer. And it's not even going to run. It's going to be like, nope. In fact, this one's actually giving me something here, the possible lossy. Let's not worry about that. That's a fancy way of saying like, it could kind of work, but it gave me a float. We're going to lose some values here if it has a decimal.
I'm also noticing that you didn't need to do QWERTY.add.
I didn't need to. I could. Only because it's within the same class. There. There we go. Yeah. So his observation was, how come I'd like, not how come, but like, I just called it add, and I can do this because it's within the same class. If I was in some other class, I would need to specify, where is this like static method? It's within QWERTY. But because I'm in QWERTY, I can also say QWERTY.add, but it's like, yeah, I know. So just hold that thought. So yeah, it takes an integer, and then this right here, I want to save the result into a variable of type integer called the result. And it goes, well, this function returns an integer, so everything should be fine, right? If I go here and I say, okay, float. Now it's going to be like, that function returns, that static method, returns a float, but you're trying to put that into an integer. No. So it's going to be a little angry. Now void is like, well, what if I have a function like this, which I would never recommend that you write because this is very side effecty and weird. Usually you have your IO at like your highest level, like in your main. Hi. Oh. Right? But notice that this function doesn't need to return anything. So because of that, you would say void. And then, well, this is nonsense. This is nonsense now. A and B are, I mean, the function gets those values and does nothing with them. But so like this doesn't return anything, so it's void. The return type is, well, you're getting nothing back. Yeah?
It gives an error otherwise, right? If you make it void.
If I don't do anything, it's going to be like, what's the return type?
It's like if you're not returning anything but you specify like this, yeah.
Well, let's see what happens. Yeah, missing return statement. Yeah, it's like, well, you got to be returning an integer. And then sure, I can shut it up by being like, I don't know, return 0. But now I'm working really hard to do it the wrong way, you know? Yeah.
When you put in 4.0 to show that it didn't work, it said that the class 4.0 was double. What's that about?
Double. That's a fancy way to say. Good observation, by the way. I was going to talk about this in a moment. Double is a float, but it's a double precision float, meaning we use more bits. Do you remember how I showed you that weird thing in Python where like 0.1 plus 0.2 is equal to 0.3000000000001? And you're like, well, that's an issue with floating point precision. So in Java, typically, we're using doubles, which has more bits, double precision. We use a lot more bits, and we can get more precise decimals to eliminate funny stuff like that. You can make float types, but usually you're going to want to use double types. Integers use, I can't remember. In Java, I guess the default in integer is 32-bit, but there's also something called a long, which is 64-bit, which we actually use in assignment 1 because the populations of continents get bigger than how much 32 bits can store, which is interesting. But you'll see that in assignment 1. Any last questions before we wrap up for today? We've covered a lot in today's lecture just by chatting that in the next topic we'll review again and we'll probably move a little faster because of it. Yeah? Getting into it? Here, just come, let's see if we can figure it out right now.